So in the early part of the 20th century, people got interested in atoms' anatomy. So people got interested in what atoms are made of. It turns out there is 3 particles that almost every atom has. Every atom has guaranteed to have 2, and every atom apart from 1 has a 3rd one. And these 3 subatomic, so smaller than the atom, particles are composed of 2 charged ones and 1 neutral one. So the first charged one is the electron. And if you've ever rubbed your head and got a static charge, you've essentially created electrons, rubbed them off your hair. And they are negatively charged, and they have a very small mass of about 9 times 10 to the minus 28 of a gram. The second particle that every atom has is a proton. And the protons have the symbol P plus because it's a positively charged particle. We write a plus there, just like the electron is a negatively charged particle. We write the minus there. And it's got a mass almost 2,000 times larger, so 1.67 times 10 to the minus 24th of a gram. The third particle, which was discovered much later, mainly because it has no charge at all, so it was much harder to discover and notice in an experiment, is the neutron. And it has a mass almost exactly the same as the proton. In fact, to 3 significant figures, it is identical. But for some strange reason, actually, if you go out to a 4th or 5th, you can detect a slight difference. So these are the 3 fundamental particles that go inside pretty much every single atom, apart from boring old hydrogen. Our book has a nice table of these 3 particles here again. The electron, the proton, and the neutron. You can see the masses here. Now, if I take them out to a few more digits, you can see the slight difference in mass between a proton and a neutron. What's interesting, though, is that the charge on the electron is negative and the charge on a proton is positive, but the units of charge are coulombs. An electron has a charge of minus 1.6 times 10 to the minus 19 of a coulomb, and a proton has a charge of positive 1.6 times 10 to the minus 19 of a coulomb. Most of the time, we don't want to keep writing out this value here of 1.6 times 10 to the minus 19, and so we just do it in multiples of that. So we say that the charge of an electron is minus 1 charge unit, and the charge on a proton is positive 1 charge unit, where this is the fundamental charge unit, sometimes written as E. So this would be minus E, and then this would be plus E. So that's probably the last time we'll mention that in this course, but you should be aware.